I think if you guys are ready, we can get started. I know a couple of people said they were coming later, and at least one person said she would look at the recording, she couldn't make it. But I think because we moved to a new room, and I know, and I guess I should say we're here because they have a visiting professor coming to IUNI today, so he's using the conference room, and they're having meetings all day, and so I think that's why we don't have any of the IUNI people here. They're all meeting with this guy, and that's why we got moved over here. So if this room is, I thought it was good because it's the center of campus. It's probably a bit big for what we need, but I thought it was kind of close for everybody to get to. I don't know, does it seem okay as a backup? Or maybe we can do it at SPIA next time. I think you guys will SPIA, right? So it might be easier. Yeah.
Actually, I don't think we should be available, but we do have like group collaboration rooms in SPIA.
Oh, okay. Yeah, that might be better because I don't think we can really move these. I mean, I think if you call ahead, they'll move the tables around, but I don't think we can move them around right now. Yeah. Yeah. Maybe we'll try that. Okay, that'd be great. Yeah, I mean, hopefully from now on we'll be able to just use our conference room, but I never know. And we'll see how it goes. But say if it is only the four of us next time, then maybe, it'll be a little easier to collaborate and work together. All right. So I put up the GitHub. I know a couple of people had emailed me in the week as well saying, how do I get connected and everything? So this is IU's GitHub. So if you have an account on github.com, you need a separate account for this because this is IU's internal version of it. So there's a knowledge base page I was looking through, and I think you said you can connect with the CAS login and create an account. Okay. So it has, and I think they have a whole library of all different things about Git at IU. So you can take a look there, and this is our group. Is it okay to use Git? Would you prefer like a box folder as well? Would that be easier just to put files up there? I thought with a Git repo, then we can collaborate, and if people want to make changes or add things they've been working on, but if you're okay with that, we can keep doing it. But
forcing people.
Yeah, well, yeah, I guess that's the other advantage, right?
At least it's good for me.
Yeah. I mean, it's not super important that you have all the materials yourselves, but just if you want a copy of what we've been doing, I'll make sure I store everything there. And then the Slack one, I'm less familiar with Slack, but I think if you create an account with Slack and then follow the link that I send out, and I can send it again if needed, then it should take you to the channel, to the different chat. I guess they're not called chat rooms anymore, Slack channels, I guess they call them. Yeah. Yeah, I think to the mailing list there should have been a. If I can find it again here. I can invite you by name if you want to. Maybe I can just do that to everybody on the list. Yeah. But yeah, give it a try, and I mean, if you want to do whatever works, but I thought there was some good, useful ways to collaborate. So like I say, hopefully we can make this more than just a meeting, make it a way for us to share information and ask questions, that kind of thing. Oh, hey. Hey, welcome. Well, no, we're not the only ones. So just saying, usually we'll be at the IUNI house, but today we're here. So they're using the conference room, so they move everybody over here. But I thought this was a better, more central location. So I started off with this file. I added the slides from last week to get, and I've created this one, which starts off with kind of a summary of what I was trying to talk about last time. And then we'll go into some more stuff about reading and working with CSV data today, and then some more data structures. And then as I was going through it all, I was getting so bored just doing like data manipulation and selecting component, all of these kind of things. So I'd done a separate part on ggplot for graphics and visualizations, which I thought we could look at as well, which will, I mean, if you've never done any R or programming, it'll introduce some ideas about functions and other things that we haven't talked about, but hopefully it'll still be useful even if we haven't got that far. And it'll hopefully at least be more interesting than just me talking about data frames and vectors the whole time. So this is what I think this is what we talked about last time, is assigning values to variables. I don't know if I mentioned it or not, but the hash character is the comment character with R. So anything after a hash doesn't get run It's just a label. You can see typos in there. There you go. And then assigning character values, assigning integers, Boolean values, logicals, creating a numeric vector, and creating a character vector. Make sure I created those because I think I'll use them later on. So you can look at I think this is all stuff we covered last time, but there's my numeric vector. And so I spend all day on the computer, but I'm still terrible at typing, so there's always going to be typos. You have to bear with me. So you see with the character vector, it's got both numbers and text, but they're stored as characters in the vector. And of course, you can always check. Should give them shorter names. The type with the class function. You see that's a character rather than numeric. And then something I'm going to talk a little bit about in the first half today, that'll come up again at least, is the square brackets for selecting elements within a data structure. So in this case with our vector, by placing the square bracket here is going to select that numbered element from the vector. So in this case, the first element is number 1. And this one, looking at the 7th element, 7. Hopefully fair. And if you've done Python, you're probably familiar with vectors similar to selecting elements from an array. And the class function and the length function. You can see how many values we have stored in the vector. And then one command I couldn't remember if I talked about last time or not is the length function. No, sorry, not the length function, the question mark. So if you prepend a question mark before a function, it's going to search for information about that function within your environment. I don't know if I covered this or not. I was trying to remember because we stayed after and did some other things, and I was trying to remember what I talked about there and what I talked about in the group session. You see a question mark followed by the function name, and it'll bring up the description of the function in your viewer here, and the arguments and value types. Which can be pretty useful as you get, if you start using more specialized functions from different libraries and things, having a quick reference to what's required to make the function actually work can be pretty useful. And then 2 question marks. So 1 question mark searches in your current environment in R. 2 question marks will go out to the web and search the CRAN website and just search all of their documentation and return any occurrence of where it finds that function name in different libraries and different vignettes. You see all these, we've got the data table library has a length type function, true length from data table. Future library has a different kind of length. So if you're ever trying to find something and you can't remember what library it's from, that can be a better way to do it. So any questions about what I talked about last time? I don't know if you've ever thought about R much in the last couple of weeks, but it all seemed, well, it wasn't too boring. I'm afraid it's going to be more boring today at the beginning as we get through the fundamentals here, but so I tried to mix it up a little with some plots and things. But so today I was going to start talking about working with CSV data, how you load that into the R environment, and then move on to data frames and lists for storing data, and matrices, and showing how you can select elements from them and subset them. And then we'll move on to plotting, which hopefully will be more interesting. So to read a CSV file, it's a fairly simple command, just read.csv. That's part of the base R environment. So that's any R installation. You don't need to load any libraries or anything. That's automatically going to be available to you. The first argument is the file path, including the name and the suffix of the file, the extension. One note though is if you are on Windows, if you look at a file directory in Windows, you'll see you have backslashes, but you'll need to transpose those to forward slashes. And if you're on a Linux system, and I think macOS as well, they probably use forward slashes, certainly Linux systems as well, but just with Windows, you can't just copy and, or you can copy and paste, but then you have to go back and change those. Or if you want to, you can use a substitution command and switch them out if you need to do it repeatedly. So I was just checking. I thought someone was saying they couldn't hear us, but it's just the Slack bot getting in touch, checking in on us. So read CSV has a number of different arguments. Now we'll take a look at some of them, but these are the ones that I find I'm using most of the time. So the header function, or the header argument, sorry, tells the read CSV that the CSV file you're looking at has headers in the table. So the first row will be treated as column headers. It's probably better if we actually take a look at this file. So this is my file of all the people who contacted me to be part of our group. I kept a record of everybody, and then we had to work out the ratio of students to staff to see if we could buy food last week for the event, to buy the sandwiches. Because if we have just staff, we're not allowed to buy sandwiches, right? Exactly. Everybody's information. And as you can see, not everybody made it today. But we'll see as we go forward. We may get more people coming back or watching remotely. So this is the file we're going to be working with. Just it's not too big, and I had it readily available. There you see it's just the 3 columns. It's all going to be character data. There's no numeric data in this example. So then I think I mentioned, I'm not sure if it was after the class, perhaps in our second session, talked a bit about strings as factors. So when you're reading a CSV, it's going to read the characters as strings with it set to false. If you read it as a factor, factors are a way to store additional data about your data set, so they can be used for categorical information about the data. I'm not going to give a great explanation because I don't really use them very much. But setting them to false means your text data will just be a string. There won't be any additional information about that string, which is not a great explanation. But I guess I say to you guys, you can look that one up. Because I'm going to get it wrong if I try and explain it. But at least setting the argument to strings as factors equals false. Make sure your character strings are only character strings. There's no additional data associated with them, if that makes any sense. One thing I look at, so you see the next, I got read CSV here. Can you see my cursor if I gesture with it? Yeah, I can point to things. So they gave me this as well. I got a laser pointer, I think, but if I don't need it, oh, well, maybe. Oh, yeah, it's there somewhere. Anyway, all right, I use my cursor. Oh, maybe, yeah. Yeah, it could be. I'm going to burn out the pixels or something. Right. Yeah, so read CSV is actually a specialized, or is a subset of the read table function, which I can show you. So basically, read CSV is read table, but it sets the delimiter, the separator value to a comma by default. So you see if you search, do question mark read CSV, it brings up the page for read table, because really they're similar things. But you see if you're using read CSV, I guess read CSV2, sorry, says the separator. Oh no, it's a decimal. Separator is a comma. There you go. So they can be used almost interchangeably, but if you use read table with a CSV, you have to remember you need to set the separator manually to be a comma. The advantage of this is, of course, if you're using data which is separated by something other than a comma, you can use read table to set it to whatever you need. And I think looking at the documentation here, you can see read CSV2 sets the default to a semicolon by default. So it just can be a quick shorthand. But I thought it was useful to point that out. I think read table also has a useful feature that you can say how many rows you want to read from the file, which can be useful if you have a file which is too big to fit into memory, and you just want to read it, sort of stream through one row at a time, process that row, do something with it, then do the next row. I believe that's in here, but unless I'm thinking of a different function, which, yeah, probably not too helpful. All right. But in both cases, we can run this command, and we're going to create a data frame. So I assign the value of the contents of of that CSV to this object, our group. So here we have our CSV data now loaded into our environment, so it can be accessed and by R, and we can manipulate it using various our tools and use it for our different visualizations and whatever we want to do with it. Actually, I think I do use that one. Okay. So a data frame is probably the most useful way to work with data in R, simply because it's a table, and that's how humans think about data. It's certainly how I think about data. I find it a lot easier to sort of conceptualize what I'm doing when I'm thinking about tabular data like this. And it can be used to store a variety of different data types. So it doesn't have to be all the same. It doesn't have to be all numeric or all text or character data. You can use it to store different types, which again can be useful. And I think pretty much most of what I'm going to do is going to be based on working with this data frame and showing you how to subset it and select elements from it and how to combine it. Oh, did I not put it onto the... If I didn't, I can add it quickly if you want to. No, it looks like I didn't. I mean, add it to Git. There you go. Put a copy so it doesn't break my link. You have it? I'll do a quick Git tutorial.
So I'm getting it out of GitHub. Can you show how to get from in Slack how to the files inside?
Which file? Oh, sure. Yeah. Hold on. Let me just run this and come back to it. Don't worry. What am I trying to do? Hopefully that worked. Yeah, I'm not much of a Git expert either. There we go. Okay. Yeah, so this is our GitHub page. It should be public if you have an account with IU's enterprise GitHub installation. It should just be this address, github.iu.edu/IUNI, our group, and that'll take you to here. So I'm going to put all the meeting materials into here, but obviously you're free. You should be free, if I've set the permissions correctly, to create other repos for other projects or other issues that might come up. Yes, I believe so. Yeah. But it's not super important if you follow along with what I'm doing, right? Through the tutorials, but I should make it available. If you wanted to follow along, yeah, if you'll download the CSV and put it in the directory, you'll need to change the path here to wherever you save it to. But yeah, I'll say feel free to use any CSV file you have available. Mm-hmm. Yeah, it should do. I mean, providing it has a header and everything, you'll need to, if you don't have a header, then don't use that. You see with setting headers to true, that sets the column names in the data frame, you see, are the headers from are the first row from the CSV file. So that's how we can reference then the content of each column by the name across the column. Do you want me to take a look? Yeah. I could, I mean, if you want to. You guys try carry on, or do you want some more time to download things? I mean, do you want me to come take a look? Yeah, sure. Let me come over, don't worry. There you go. This should be the name of the, I don't know what they call it in Git, the organization. And then within that, meeting materials is the repository you want to load. Yes, that's the script I'm looking at, and then I think that there should only be one CSV if you wanted to use that one, but obviously you're free to use your own, or however you want to do it. And as saying at the beginning, I'll try and do some of the ggplot2 stuff as well, because otherwise it's kind of dry just doing all of this subsetting and data manipulation. And plus that's what a lot of people had said they were interested in learning how to do charts and visualizations. All right. So those are the base functions for loading CSVs. I also included just a quick, or just a single command from the XLSX library for working with Excel data. It's probably what I thought most people would be familiar with when they're working with tabular data. So if you have an Excel file, if you include this library. Now I think I covered it last week, you have to install a package before you work with it. So I've already installed it, so I'm just running this, by running this command, making the contents of this library available in my environment and all of its functions and various things. So I have an Excel file which is just the same format as this one. So this is a CSV version. I have an Excel one as well. Yeah.
I'm not going to worry about it.
Okay.
Everyone in every R video I watch
Right.
about Excel files. So first off, don't. Second off, figure it out.
Yeah.
So
Yeah, it's probably better if you have an Excel file, save it just as a CSV and then work with it that way. But just if you have to, if you need to. But obviously, yeah, the Excel file I'm using for this example is one that I created so there wouldn't be any problems. So it is kind of it's not a real world example. So yeah, maybe I'm making it look easier than than it is working with Excel data. Yeah, exactly. Hopefully this command will run and just, give us the same data frame. There we go, as we had before. But it's a nice feature though. You can specify the name of the sheet. So you don't have, if you have a file with multiple sheets, or Excel file with multiple sheets, you can select from that one. All right, so these are all data frames. I'm going to use the R group one, but they should all be identical. Once they get into the R environment, R should see them all basically as the same. They just have different names. As I said, this is probably how you're going to do, if you're doing data analysis with R, you're probably going to be working with data frames most of the time. At least certainly that's my how I work with the data. But it depends what you're doing, I guess. So the head command, or head function, will show you the first 6 rows of any data frame. So if you just need a snapshot of the structure or the get some idea of it without putting the whole contents of it in your console view, you just need to see the first few rows. The tail command is the final 6. Data frames do have an order to them. Some data structures, they don't consider the data to be stored in any order, like say a SQL table. Unless you impose an order on it, it won't be ordered. But data frames remain in their order. They have that referential integrity by default. And then with the head command, you can also set how many rows. So by the default is 6, but as you see with this example, head data frame name, comma 10, it's going to show me the first 10 rows. So you can set it to whatever is useful for you, depending on what you're doing. Then dimensions, a dim command. So you see we have 19 rows, 3 columns. So that can be useful as you're working with you're trying to make sure I don't know, if you want to perform some operation on every row of the data frame, you'll need to know in advance how many rows you have so you can tell it what you need to do. Or if you're trying to select elements from within the data frame, which is what we're going to do here. So again, we're using the square brackets notation again to select a cell or a value from inside the data frame. And as you can imagine, we've got 2 numbers. One is the row reference, one is the column reference. So separated by a comma, this should give us the first cell of the first column. And the 2-1, see, is the second row of the first column, which always seems to me like it should be the other way around, but maybe that's just me that you think the column would come first. But anyway, I always have to do it twice because I always get it wrong the first time and do it again the second time. And so then 2 is the second element of the second column. So you can pull out individual values that way. If you need to select an entire column, then you can use the $ operator if you're selecting it by name. So our group $ column name, so in this case, the name column, is going to produce us now a vector of all of the contents of that column, which we can then assign to an object, which I've called names. And so then we can pull out a copy of that data of that column and then work on that data separately if we need to. So the subset command, this is, if you're familiar with SQL, you've probably done functions like this where you're selecting everything from this column where certain criteria are met. And that's basically what we're doing here. So we're saying subset data frame, or subset the column from our group name where the value for our group category equals student. So this should give us the names of all the people who are identified as students within the group. So let's just go back to so here's just the structure again, just to remind us. So we have the category and people's names. So every person is associated with a different category, whether they're faculty or staff or students. And this is going to give us a vector just of all of the people with the value student in the category column. I know this stuff is all pretty dry and not very exciting, but hopefully it'll get more interesting as we go through. I'm going to speed things up as well so we don't have as much time. All right, so we can, so that's how we can extract vectors from data frames or read data frames from files. And now I'm going to talk about another data structure which is very similar to a data frame, which is the matrix. So it's also a 2-dimensional array, but a matrix in our, I think I'm right in saying, can only store one type of data. So as a data frame, we can have any mixture of numeric and character or logical data that we want. A matrix is restricted to one type. And a good example, and my examples may be further on. Hey, let me create one and then we can, so I can show you. Oh, right. Okay. So I'm going to take the names value column, which I extracted here, and I'm going to convert it into a two-dimensional array. But no real, I couldn't think of a good reason to do this, but it's just as an example. Problem is we only have 19 values, so we can't easily, being a prime number, we can't put it into a table. So I'm going to append a value of an additional name to the vector names using the C command. So C is always going to return a character vector. So here's the name, I'm referencing the vector we created and then adding another value to it. And this should just merge them together. So now if we look at names, you see we've added an additional person to the end of it. And if you wanted to, if you put, say, the name before the variable there, then it would add it at the front of the vector, for example. And obviously you can continue to add and manipulate this as necessary. So now the length of our names object is 20, we can start shaping it into a matrix. So we can specify the dimensions that we want to use for names, basically. It's probably easier to run it and see it than it is to explain it. So by setting it to 5.4, I've now converted names. Let's try and make that more visually appealing. Sorry. There we go. So now we've got 4 columns and 5 rows. So we've taken that vector and shaped it into a matrix by setting a dimensions, by applying a dimension argument to the vector. I couldn't think of a good example of why you would want to use a matrix with character data necessarily, but in general, matrix data uses less memory than a data frame object. So if you have a very large data set, it can be useful to work with a matrix of data if you can, rather than a data frame, just so you can hold more of it. But I think one of the main uses for matrices is for doing matrix algebra and linear algebra and storing that kind of data, which I'm afraid I'm not going to give you any good examples of, but I think it's useful to know. And of course, once the data is, once you have this kind of data, you can start reshaping it however you want. So here we have 4 columns, 5 rows, but I can apply a different dimension to it, a different dimension argument, and now I have 2 columns, 10 rows. So I can start converting it and reshaping it how I want. I guess that might be a good reason why I would want to work with it this way, is because it's so easy to change the structure of it like that. Whereas a data frame is going to try and tie you more into making sure your rows and columns stay aligned with one another. Hopefully we'll see class is, matrix. Okay. And then you can select elements from a matrix the same way as you would with a data frame, using the same square bracket notation. Actually, before I make that claim, maybe I should try it to be sure. Yeah, there we go. Okay, so the other data structure I wanted to quickly cover before we start moving on to the plotting is a list, which is probably something I use probably a lot more than I do, say, the matrix in my day-to-day work with R. But obviously it depends on your situation. A list is a hierarchical data structure, and again, it's probably easier to see it than it is to discuss it. But if you're ever working with sort of JSON data or XML data, that can be a good use for a list. I haven't covered that today, but maybe that's something we can talk about in the future, or in a discussion how to read and work with XML and JSON files. But a list, like a data frame, can hold data of any type, but it can also hold data structures themselves. So for example, a list can include, look, here's my argument here to create a list. So the argument is just list, and then whatever's in the bracket will be put into the list. But I've got my data frame here. I have the vector. I created names, the matrix names. And then also I pulled out the column email, which will be a character vector. But I can put them all into this same object list, which, let me show you how that looks. And again, I always forget the quote. My coworker Ben says that two things are difficult in computer science. It's like segmentation faults and coming up with names for things or something like that. So that's why we have my list and my vector, because I didn't come up with any better names. Oops. So here's the list. So you see the first element of the list is the data frame. The second element of the list here is the matrix, and the final element is just that single column from the data frame, the character vector. And so we can continue to add things and expand on this or select elements from it however we want. And then this next one, I'm going to show you how you can have this, I mentioned this sort of hierarchy to it. So I have my list called my list, and I'm going to add a sublist to my list. So a list can contain data of any type, including another list. And so you can continue to sort of expand it with different levels of data. Exactly. Let me show you how that looks. Oops. Oh, I should have mentioned as well. So the values I'm putting into this sublist are the numeric vector and character vector that I was looking at the very top. So there'll just be two arrays of numbers. So you see, here's our initial list. And so now our first level for our list is level 1. So we have 1, 1 is the data frame, 1, 2 is the matrix, 1, 3 is that character vector. And then here's our second element of our list is the second list. So 2, 1 is the numeric vector, and 2, 2 is the character vector. And of course, if I wanted to, I can append more lists to that sublist, and as many as I want. But again, that's probably not very useful, because at least I find it difficult to sort of kind of keep that in my mind as I'm working with the data and keep track of it. So we can select elements from a list in a similar way, again using the square bracket notation. So that's returning the first list. So you think our list has two main levels? We have that first list we looked at, the data frame, matrix, character vector, and then the second list is the two vectors from the beginning. So by selecting my list 1, it gives me that first list. My list 2 gives me that second list that I appended to the list. Is that? I know maybe it's not super, I don't know. I feel like I'm just repeating the word list over and over. I don't know if there's a better way to explain it, but maybe as you work with the list's structure, you'll get more familiar with it. So you see with the list, because we have these different levels, rather than doing the row column numeric annotation like we did with the data frame, we start selecting these sub elements from the list. So looking at element 2, which is these two vectors, and taking the first element from there. You see it's, that's not right, on the right one. Oh, okay. So the first element from that sublist, is those two lists itself, which is not very interesting. But if I look at the second element, so then that's giving me the character vector. Does that kind of follow? So I'm looking at the second list, but the first element of the second list are both of these. But the second element of that first element of you see, you start getting into this kind of notation to actually get down to the vector itself, because this is the second element here. So this is what I want to talk about, I guess, two square brackets versus one square bracket. Oh, here, maybe this is a better example of this. I'm going to use the analogy. I brought a book here. I didn't want to seem patronizing when I give you this analogy about trains, which they use. You see there's a picture of trains here in the book. I didn't want to. Yeah, just to prove I wasn't just making this up and talking about trains. So the analogy they give for you, the difference between a single square bracket and a second square bracket is that if you, you brought the book so I would get it right as well, but I didn't want to mess it up. So when you use the single brackets, R selects the individual train car and returns them as a new train. So you have the car and you have the contents of the car, but they're still inside the train. When you use the double brackets, R unloads the car and gives you back the contents. So the idea is, if using the single brackets, R So if you use a single bracket to select an element from a list, it's going to return to you a list with the contents of that list. If you use the double brackets, it's just going to return you whatever the content of that list is. So for example, with our list, one of the elements of our list is a data frame. If I selected that data frame using single brackets, it would return me a list with one element, which would be a data frame. If I use the double brackets, it's going to return just a data frame itself. So you can think of the trains. And I remember there was an analogy about trains, but I couldn't remember what it was, so I had to go look it up. So I don't know if it's helpful to talk about it that way. But so you start to see the difference here. And I think maybe the best way is, to work with this is to download the script and just sort of run each of these and then look at the outputs and see that as you work out the differences between them. But by using the square brackets in the middle here, you see it still returns a list because the final option is a single pair of square brackets, but it's returning the contents of the first element of the second part of the list. That makes sense? Yeah. Mostly when you're getting into this kind of complex structure, it's if you've got a JSON file or an XML file, which has come from a website, or one we get is the Web of Science data set, which is a big citation network graph. And they send us the data as XMLs, but it's so, it's so densely structured like this that in order to get to one individual element, you have these long strings of square brackets and double brackets. But yeah, I don't typically build data objects this way, but often you'll be working with data which is structured. And this is just how R handles it. There are better, obviously there are shorter hand ways to do it. If you're working with XML, there are XML libraries which will help you parse it and sort of mean you don't have to do this kind of thing. And but this is just sort of the fundamental way, the basic way to do it. Yeah. So yeah, that's probably why it's not very intuitive. That's why they created the libraries. So you don't have to memorize all this kind of stuff. So yeah, what was this section? All right, so this is the example where I'm using the double brackets at the end. So here's the difference between them, the single and the double square brackets. So this one returns a list, whereas this one returns the contents of the list, which is the vector. All right. So, and then, so here's an example of where you might want to do this kind of thing. So it's taking multiple elements from a list and converting them to a data frame for whatever purpose, future analysis. So I don't know if it's worth getting into the details of exactly how this one works, but just to show you that it does work, you can do this, and that you can you can take pieces out of a data frame and combine them together to create a list. So this is going to select those two vectors, right? And because they're the same dimensions, they both have 10 elements, I can then combine them into a data frame using this rbind data frame and just repeating it using do call, which again, maybe we can talk about more in a later session, but the basic idea is now I have a data frame, a kind of ugly one, because I don't have any column names, so R is just sort of building column names for me. But that's too wide. But the idea is now, so I have those two list elements and I've put them into a data frame, into a new object. So that might be a case, I say when I'm working with those XML files that have a lot of layers, being able to pull out a few, a section of it and then put that into a data frame or a vector or whatever can be a much better way to work with it than trying to work with the whole thing at the same time. And then here, so because this is all kind of a mess, I was going to show you how to clean it up a little bit, which can be helpful just for your own sanity when you're working with the data, as R starts spitting out stuff like this and you can't really, it makes it much more difficult to work with. So here I have the function T, which is for transpose. So I'm just going to flip the data frame through 90 degrees. Instead of 10 columns, we're going to have 2 columns. But transpose generally will output a matrix, so I'm going to convert it to a data frame with the data frame function. So then I assign that back to outdf. So basically it's overwritten the previous object with the 10 rows, and it now should give me, there you go, 2 columns with 10 rows. So it's just rotated it there. But it's still kind of a mess because I have all of these, what were the programmatically generated column headings from the list as my row names. So row names with applied to a data frame will just return either names like that as a character vector. So if I set those to null, so I'm assigning the value of null to all of the row names in my data frame. I should now, no, I just have the standard sort of numbering, indexing that R gives the data frames. And then my column names, x1 and x2, not very helpful. So I'm going to assign new column headings using col names argument, which again, col names, why it is row dot names and col names, I don't know. I think it's mainly just to cause problems and confuse you. You forget which one you need, but that's how it is, at least with base R. So this is my character vector I'm creating here. So I have one numeric, one character. I mean, if you want to rename an entire data frame, if you want to rename every column, you'll need to have some value for each column. I won't let you just assign a blank. I mean, you can assign a blank value with two what do you call them? Two apostrophes or two quotation characters like that, and then your column won't have a name. You can't skip a column, basically. You've got to assign a value to each one. So then this, yeah. So now I have my data frame nicely presented, and I can start working with it. And also now I can subset it again. Yeah, and I have names that I can type easily. So I can start taking out pieces again if I want to work with it or change values. So we only have about 10 minutes. I did book the room until 5 like last time. So if you'd like, if you have questions about anything we're doing here or something you want me to talk more about, or I can start on some of the plotting parts if you like, or if you need to go, that's fine too. Don't worry. But whatever you'd like to do, or if there's anything you particularly want to talk about or issues you've had with that have coming up, because I don't want to just lecture you guys the whole time.
This room might be helpful.
Yeah, we are in a more of a lecture environment today. Yeah. I know I went through some of that fairly quickly, particularly the list stuff is not particularly intuitive to see it. I think you've got to just try and sort of work with it and get an understanding and a feel for it. But I did.
Especially like R works really well with, rather than like in state or whatever used for a dummy variable, it used to be a character or a boolean, right?
Yeah.
And kind of make that mental conversion, and also like trying to break out like a variable with like many levels into like what data was just like a bunch of dummy variables, right? So for like the 50 states, sometimes I would dummy it out to a bunch of states, and like trying to do that in R is what that's the sort of corner I'm trying to.
Yeah.
That's sort of the best way to do that, right? So like if I'm running just basic regression,
Right.
sometimes you just dummy it all the way out so that you can get the best fit and figure out the interest, but to have it figured out how to do that more. It's like one minute.
Yeah, I mean, yeah.
Variable and then
Right.
that in the regression.
I mean, I think that probably, I can look into it. I'm sure there's a library for dummy variables, so I can show you quickly how to assign it or build a variable like that for a data frame, if that's helpful. Yeah. Right.
It's not so much, I kind of know now like how to assign just the basics, right? How to assign
Right.
a variable
Yeah.
and that sort of stuff, and trying to get like that. So here's the part where I'm trying to figure out is like how do I create a variable like Indiana,
Right.
Then do I just say like, so create essentially a dummy variable, do it like a logical
Sure.
And then do like Indiana, assign it, if there's like a categorical variable of like the state, then I would do like state double assign Indiana.
So if you want to add a variable to the data frame,
Right,
or,
add-
yeah.
essentially
Let me,
it's a
yeah.
variable,
Okay.
but stays categorical, so it's not used. Well, I guess it could be as a dummy, so you want to use it as for
Right.
0
Exactly.
and 1, so that I get the
Yeah. Look. Sure. So if we have a data frame which is something like equals 2000. I'm sure there's a library that will generate years, but I don't know, so I'll just do 5. If I can even type them, yeah, that would make more sense.
You're too far on that. You can't go back.
But yeah, it happens.
cost fallacy.
Well, yeah. Then, why don't we just make it, I don't know, just make it a number. All right. Oh, did I show you the view command last time?
The what?
View? Maybe I should. Yeah. I didn't talk about it. I don't know. I couldn't remember what I talked about at the main group meeting or not. So view will pop up a data frame in its own window like this. Search is it can be a useful way to look at it rather than just looking at it in the console.
So like if you wanted to create
A dummy variable like here.
everything in the file.
Okay. Not a problem. Now I say there are probably libraries that will make it easier, but I can show you the way to do it, like with base R. So if I want to add another column, I simply create what I want to call the column in the same way that I would subset a column. So first of all, I'm just going to use the number 0. So let me do it and make sure it works before I tell you. Start. Yeah, okay. So if I just give it one value, but assign it to a data frame with a certain number of rows, R is going to repeat that value across the length of the data frame. So now we have our column, which is all zeros. So if I want to assign a value to, which year did we say? 2002? What was that? 3.3? So I can do sample 3.3. Does that work?
Yeah.
So yeah, so I guess, yeah, the same way I've been talking, I guess, today about selecting data from a data frame, but you can also put data into a data frame using those same set of tools by selecting columns and rows or adding columns.
Is there, so the certain control, I've got like the data I'm linking with now, like 1500 observations.
Right. Yeah.
So like I want all the mail.
Right.
Right, so is there a way to make that sample dummy equal 1 for
Every value of,
for
yeah.
every mail? And like in this instance,
Right.
instead of saying element 3.3, can we say like equals 1 given that year 2002?
Yeah. Yeah, there should be a way to do that. I'm trying to think off the top of my head.
Or like,
All right. Yeah, yeah.
Value X
Mhm.
in the column,
Yeah.
in the column.
Just loop through it row by row. Yeah, I'm trying to think. Yeah, yeah. Yeah, yeah. No, you could do it that way.
I'm sure, I've got to go, but I'm
Yeah,
sure
yeah.
like just, I'm just playing around with it. My survival analysis class was in R, so.
Right. Yeah, yeah.
I could have so much guaranteed as like a package.
Yeah, that's what I'm thinking. That'd be a way to do it. But you could do it with a loop and just loop through each row and just say, if this value equals m, make this 1, otherwise 0. But yeah, we haven't got to for loops yet, or if statements. But yeah, there would be a way we could do that. Yeah, sure. Well, yeah, I guess if we're, people have to go now. Do we want, next time, would we rather do like the charts and plotting I had prepared, or do we want to do control statements like for and if and that kind of thing? Because, yeah. Okay. Okay. Right. Yeah. Okay. Well, yeah. I mean, I'll take a look at that one and say maybe if that's that's a use case, an actual example we have. Maybe we'll do for loops next time and just go through different ways we could approach something like that. That might be a good introduction to some of that stuff. Cool. All right, well, thanks. I hope it was helpful. I hope it wasn't too boring. Hopefully we've covered all the most boring parts, like the fundamentals of just selecting and data types and that kind of thing. So I'm getting some more interested. Yeah, absolutely. All right, see you next time. 2 weeks. Yeah, yeah. Hopefully back at IUNI, but I'll send an email. All right, bye. Yeah, how to do it. Yeah, I'm sure there is a library for dummy variables.
A dummy, like a get dummies function in Python, so I'm sure.
There you go. There's a whole article about it. We can look at. I'll go through it and see. But yeah, like you say, I mean, there's you could do it with a loop. That's going to be relatively slow in R, but that would work. And if it's only something you have to do one time, it's probably not an issue. Yeah, I guess we can talk about difference with R with functions and loops. In general, with R, functions tend to be faster, particularly if they're vectorized. But it's probably more than we want to get into today. I don't know. But a lot of that's, I mean, R is designed for that kind of data analysis. So a lot of those things you'll find there. Oh, here you go.
Yeah.
There's a whole library called fast dummies. Yeah. So I'm sure there's something pre-written rather than having to do it yourself. Yeah. Yeah, I'll take a look, but yeah. Cool. Yeah, how are these cool plots I was going to show you guys, but I can save them for next time. I'm going to show you can do like GIS stuff with ggplot too, which I thought was cool. But
Basic, yes, of course.
Yeah. Yeah, this is, I think, restaurants in the south of France. So I guess this is the coastline here. But yeah, one thing I guess I'll put on the Slack or the mail, where is it? I had a book I found. One of these, maybe. Yeah, this is our graphics cookbook. I'll put it into Slack, but it's like a whole O'Reilly book just on sort of visualizations and visual tools. So I was going to use that for the plotting stuff, but I can share that with the group by next time. So
graphics would be super useful. I think like one of the things is that I don't know, you can't plot anything until you manipulate your own data.
right,
And
yeah.
lean on the side of we need to do more data manipulation.
Right. Yeah, I'm just worried that we're going to put people off. I mean, we had about 15 last week, and now we're down to 4. So more people are going to get bored if I keep going on about data manipulation.
I actually have like a bunch of people in my program that would have been interested,
Yeah.
but they all put off a required course.
Oh, sure.
And I'm the only one not in it.
Yeah.
They're in that class right now.
Well, I'm hoping as well we can make this, like, I started out just doing some lectures and things, so hopefully we can have it so people can jump in whenever they want, and at least, even if they don't know all the fundamentals, they can get involved. And I don't want it to be like a program where if you're not here at the start of the semester, you're not allowed to be part of the group or anything.
Yeah. I was thinking about that actually.
Yeah. Yeah.
I hope people don't feel like.
Yeah, well, that's what I was thinking as well. If I can get Olga to come next time, she does a lot of natural language processing work with R, which I know, people here said they're interested in, which obviously will deal with a lot more advanced concepts and everything I'm going to cover in my lectures, but I think it's still interesting and useful, even if you don't follow all of it, to get some idea of what's available and how it works and that kind of thing.
That would be
Oh.
functionally allowed.
There you go.
Which
Yeah.
I did it once in a class.
Yeah.
In Python, and I was like, I cannot do this.
Yeah, Olga's a linguist, so she has a bunch of stuff like language tools, but she built a whole shiny like app which you can like upload files and it'll process the text and everything
That's
and
super cool.
all kinds of stuff. Yeah.
That would be amazing for me.
Yeah.
I don't know about other people, but I'm always actually worried I might get an interview and have to do
And have to do it, yeah. Yeah, there's some, I mean, there's, well, I say I've looked at some of the text mining stuff. I can't tell you if it's good or not because I don't have any experience with any other set of tools, but there seem to be quite a few ways to do it and resources out there. So yeah, we can try and do that. Cool. All right. Thanks. Sure, absolutely. Thanks for coming.